This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio is brought to you by the IEEE Computer Society and by IEEE Software Magazine. Online at computer.org/software.
Collide sends employees important, timely, and relevant security recommendations for their Linux, Mac, and Windows devices right inside Slack. Collide is perfect for organizations that want to move beyond a traditional lockdown model to one where employees are educated about security and device management while they're fixing important problems. Visit collide.com/SERadio to sign up today. That's KOLIDE.com/SERadio. Enter your email when prompted to receive your free Collide gift bundle after trial activation. You can try Collide with all its features on an unlimited number of devices for free for 14 days. No credit card required. Try it out at collide.com/SERadio.
Hello everyone, this is Felienne for Software Engineering Radio. Today with me on the show, James Socol. James is an engineer and leader with experience on all parts of the web application stack. He is currently a senior staff engineer at Policygenius. Previously, he has been a director of engineering at Condé Nast and he's also worked at Bitly and Mozilla. James is an active member of the Python and JavaScript communities and maintains several popular open source software projects. Welcome to the show, James.
Thank you for having me. It's great to be here.
So the topic of today's show is CICD. And we're going to dive into all sorts of aspects of that. But first, let's discuss this separately, because very often we say CICD. But actually, what are the parts there? What is the first part? Continuous integration. What does it mean according to you?
Yeah, continuous integration is, I think, an important and worthwhile step in and of itself. But when you're continuously integrating, you're taking small changes and bringing them back into the sort of main code base all the time, as opposed to something like you've got a long-lived feature branch or a release branch. Sometimes people also call it trunk-based development, where you're just sort of making small changes, bringing them back, and then making sure that you're running tests, builds, if that's relevant, on every change, so that it's all kind of just automated and people are always working off the most recent functioning, hopefully, version of the code.
So what problem does that solve? Why is CI testing or CI development process, why is that better than a feature branch? Or what are the differences?
I think the biggest thing that it's solved, especially in my experience, is the multiple day merge and reconciliation process of having multiple feature branches or teams working on something before one release. That was just, I've literally had teams spend 2 days resolving merge conflicts because, there's drift among different authors of code, different teams working on the same thing. The other thing is that it avoids a particular, even if it's small, a particular change bit rotting or becoming unmergeable in the first place or irrelevant. If we've got, on this one branch over here, we solved this problem already, so now you don't need to bother doing it. You can avoid that sort of a rework. But I think the biggest thing is just that if you're continuously branching and merging, each merge is so much faster, so much smoother that it saves the team a lot of time overall.
And are there downsides as well? Maybe like merging in small changes that you end up not using, or other downsides of the CI approach?
I don't know if I'd call them downsides so much as I think there are costs. The biggest one is that you may be merging code that's unused. In one point of view, that's very safe code, but that's not always true. And so you have to have some way of sort of flagging on certain behaviors or flagging it off. If you're going to merge something that's incomplete, you have to be sure that it's not going to be exposed to users. So there are some mechanisms that you have to adopt. And then there's a little bit of additional code to write and then additional code to remove when you're done and integrated and the whole feature is rolled out and you need to take those flags back. So I think that there are some costs associated with it. It's not entirely free. I don't know if I'd call them downsides per se.
Sure. And we will definitely dive into those practices of how do you make sure that you don't accidentally expose half features to users later on. But first, I also want to cover the CD part of CI/CD. Actually, CD was harder because I was looking up a few stuff before the episode. And what does CD even mean? Is it continuous delivery or continuous deployment? It seems people don't even agree what the CD stands for. So what is your take? What does it mean and how do you define CD?
I usually mean continuous delivery, although it's really worth specifying each time. It's sort of like MTTR in that respect, like which are. So continuous delivery is when you have this continuous integration pipeline or automation, moving that sort of resulting version of the code into whatever's an appropriate environment, at least for testing. So if you're doing a mobile app, that might be publishing, a new built artifact. If you're doing something where you're deploying applications on Kubernetes, it might be pushing a container into a testing cluster. But taking the artifact or the result and then putting it someplace where you can do something with it, that's just delivering into an environment. Continuous deployment is going a step further and saying that every change that passes all of those automated steps is going to production right now, which I think is a great place to be in if you can get there.
So again, here the question is, what problem does CD solve? Why is it good to put stuff to users as quickly as possible?
I think my favorite example is the hotfix. When you're maintaining multiple different branches and you have something that you need to, say you're like, most of your team is working ahead on the next release version, but it's not ready to go yet, and you discover a bug. Well, now you have to patch that bug, and you have to figure out if it exists in the existing release branch or if it's only in the new one, and it's kind of a deviation from your normal process. When you're doing CD, there's no such thing as a hotfix because everything is a hotfix, basically. Since everything is going to production, you're really optimized for making those kind of changes quickly. So if you have, we have big features that we're working on, they're turned off right now, but, we discovered a problem. It's right kind of in your day-to-day run of things to be able to ship a change to it. It also means for smaller features that don't necessarily need that, they get to users faster because they're not waiting for anything. They're not bundled up with bigger changes. And so that can mean, a feature gets in front of users faster, the business benefits from it sooner, the developer hasn't moved on and forgotten about it if there are issues with it.
So I can see how deploying continuously is sort of doable if you're developing a web app, but what if you're developing a phone app or a desktop application? Like, users don't want to update their apps daily, right? So how does that work? Is CD there not a good fit, or do you do something differently there?
So I admit that I'm not an expert in mobile deployment, but I have heard some interesting strategies to kind of bridge that gap, because you may want to be shipping and testing new features faster than you can reasonably, especially on mobile where you have App Store reviews, right? Faster than you can reasonably expect updates to go out. One of the things I've heard is using WebView fallback. If your app is like, I don't know how to render this component, it can sort of say, but I will render this web version instead, so that you can sort of keep testing out new features by doing CD on the back end. There's also definitely times when, depending on the industry that you're working in, it may not be appropriate if people need to certify releases before they can roll them out, like government or healthcare, insurance sometimes. That can be a reason not to do CD, certainly not to do continuous deployment of versions of, software to customers. There are always going to be situations in which it's not the best fit. I think getting that kind of like continuous delivery aspect of it, like let's always be testing this and be ready to ship a version of it, is a good middle ground in those situations, so that we can say like, hey, again, we have a critical bug. We need to update data logging library. We can do that right away. But yeah, there are definitely some times when continuous deployment is going to be more difficult, especially if you do need users to make updates.
Yeah, that makes total sense. So let's dive into tools that are needed. So, okay, you have convinced me of the benefits of CICD. I also want this for my app. Now what do I do? Like, what type of tools do I need to have a good workflow?
So tend to think about this in terms of what I call the Triforce of deployment. If you've ever played the Zelda games, the Triforce is these three components of wisdom, power, and courage. Tooling, I think, mostly falls into sort of the power, the capabilities that you have, but it also kind of can lean into the wisdom side. So one, I think you do need a way to turn things on and off. You need to be able to ship code that's not complete and have that be okay. Code that's even broken in the sense that it may not work at all. So feature flags are kind of the typical way that we talk about that, or feature toggles.
I'm not really familiar with this. Is there a difference between a feature flag and a feature toggle, or are they just synonyms?
I think they're just synonyms. I don't think there's a meaningful. I think there are different kinds of them, something that's like long lived and you may want to shut off for operational reasons versus something that's part of a release. But yeah, I think mostly just synonyms. Another really important tool is you need a way to automate your build process. So you need some kind of, automated task runner, whether it's something like Jenkins, if you're going relatively old school, or using GitHub Actions, or any of the number of sort of CI tools that exist now. You need version control, something that makes branching easy. Hopefully that one is at this point relatively common, but it might not be.
So you mentioned Jenkins or GitHub Actions as CI tools. So what does such a CI tool do?
Largely what a CI tool is responsible for is executing a series of steps. And so sometimes they're called pipelines because they move from one step to another along a defined progression. The sort of first step is usually some kind of like, all right, let's gather the artifact, let's gather the inputs to the artifact, figure out the things that we need to execute, like let's run tests, let's run linting, if that's a thing that is relevant. Security analysis might be relevant. And then producing sort of a build artifact of some sort, whether it's an EC2, AMI, or a container, or an APK if it's an Android app. But they're responsible for that sort of orchestration of, here's 5 or 10 steps or whatever it is. Let me execute each one of those in sequence, usually in sequence. Sometimes things are parallelizable and bail out if some part of it fails, but producing the end result, the end of the pipeline.
And you also mentioned testing as part of the pipeline. So what is the role of testing there?
I think of testing as part of a broader spectrum of sort of confidence, and that kind of falls into the Triforce of Courage. You need confidence that what you're about to ship is okay. And testing is kind of your first line of defense. If we can do automated unit tests and then, integration tests on top of that, that gives us more confidence that the code we're about to write or the code we're about to ship is correct, or is at least incorrect in an acceptable way. So, leveraging that sort of certainty and confidence that you get from having those tests pass. And then, confidence kind of continues along the spectrum. There are certain things that you need to know that you can't test. Like, I need to know that my production application is connected to my production database. No unit test will ever tell me that. So that kind of takes you forward into monitoring and alerting, which I think all part of the same sort of spectrum of how do I know it's working?
Yeah, maybe we should dive into that topic of monitoring, because now we're discussing like the happy path, right? So there's a branch, and this is a pull request or something is accepted, and now the tests run, and now everything is deployed. Hooray. But what if I accidentally deployed something where all my tests were passing, but something else happens? I get issues, downtime, whatever. So is this rolling back manually or automatically? Is that also considered part of the CICD workflow, that if I can quickly deploy, I should also be able to quickly roll back if it's necessary?
Yes. And I think that that's one of the strengths, is that if I introduce a small change and it goes to production and it causes something to go wrong, right? And that fun thing of every bug that made it to production made it through the test suite. So they all did. That I know which change introduced that, and I can roll that back quickly. Or, if I want to do a git revert and roll forward, I can do that quickly. But having the ability to ship a change very fast it's what CD is set up to do, and it's particularly valuable in that situation. If you are doing something like containers or other binary builds, maybe if you're working in Go or another sort of compiled language, and you can just ship the artifact that you had just previously shipped, you can save all of that kind of build and test time and say, this one was a known good one, let's just get it back out there. Usually, most of the tools are able to sort of redo just the last step of the deployment. If not, it might take a little longer to rerun the tests. But
so if I have decided what tools to use, how do I run the tools? So you mentioned Jenkins and GitHub Actions. Is this stuff that is typically used in the cloud, like GitHub Actions is running on someone else's machine, or would you advise having a dedicated machine in your own infrastructure there? Maybe this depends on what situation you're in. What would you advise there?
I mean, I think with almost everything, the answer is going to be it depends to some extent. But there are a number of really good cloud tools, and if I'm not interested in maintaining that infrastructure myself, and I'm really not anymore, then I see, unless I have some sort of regulatory or compliance, or I have a large enough team with the staff to dedicate to maintaining those tools, then I would rather use something that somebody else is going to operationalize and take care of. So those are the ones that I would look to first if I can. That does mean there's usually some level of setup of, if I'm running something in my own infrastructure, there might be fewer permission things that I need to worry about in terms of, pushing new code into a running environment of mine. But I think it's probably a worthwhile trade-off for most teams to say, like, I'm just going to use somebody who knows what they're doing here. So something that, connects into whatever your source controls, either webhooks, so you can sort of trigger these on push, or can periodically pull source control for changes and kick off new builds that way. But always build versus buy is a trade-off. It depends for every company, but I think there's a lot of good options out there to buy and get yourself set up.
Yeah, so I think what you're saying is, unless there's pressing reasons because you're not allowed to, just using cloud tools is a good, easy start.
Mm-hmm. Absolutely.
So let's talk about configuration of such workflows. So I want to say, okay, unit tests and then some integration tests, maybe a stress test or a performance test. These are the things I want to do before I'm going to run my CICD. What do I do? What are typical solutions there? Do I script this in a language? Do I click this together with a web builder? What are some of the solutions? And maybe your advice also on different options there.
So most of the cloud tools use YAML as sort of a configuration format. You can define, they all have variations on a similar structure of here's the steps that I want to run. And then in each step, you usually have quite a lot of freedom to sort of define what is executing. So, whether it's go test or NPM test, or you want to say, actually, this is a little bit complicated. I need to set some environment variables. So I'm going to wrap this in a shell script and then execute that shell script. But for the most part, when you're looking at configuring one of these tools, it's going to be a big YAML file. The fewer steps, the shorter it'll be, but specifying, these are the environments that I need. These are the environment variables. These are the inputs. And this is where I download everything that I, pull in my dependencies or whatever the other build steps might be for that particular language or environment. And then, if you're doing containers, there's obviously Docker files, almost always Docker files that are part of that as well. But usually it starts with the YAML. And
what about dependency management? So suppose one of my features, something that used to live in a feature flag but is now already integrated, needs a new version of one of the libraries that we are dependent on. Where do I manage that? Is that part of this workflow as well?
Most of the languages that I've gotten to work in recently have some concept of dependency management in a lock file so that you can get these reproducible builds. That's particularly valuable for the transient dependencies or transitive dependencies, right? If you don't want something changing downstream without your knowledge of it. So usually that's something that's managed locally by the developer and then sort of checked in as a change to that lock file or to the upstream dependency file. And then there are some caveats to this, but your CI setup, if you're building something with dependencies, is usually going to pull down whatever the sort of specified dependency versions are. So each time you build that particular change, you should be getting the same versions. There are sometimes when people are particularly security conscious, especially in ecosystems with lots and lots of little libraries like JavaScript, they'll use an intermediate proxy, something that they have to sort of approve new versions of code to go into from the public registry. That one is, not for everybody. It depends on sort of your security needs and the trade-offs you want to make. But for the most part, it's managing lock files is more of a beginning of the pipeline flow, and then the pipeline should be respecting whatever is in your dependency lists and lock files.
Okay, so let's talk about the practicalities of this. So we know now what tools to use, but how do I do this? Like, what type of knowledge is needed to properly set it up? In the good old days, maybe we had a system administrator that did such things, right? That deployed or that made installers for different versions. What skills do we need to get such a process going?
Well, it depends a little bit on which tools you choose to use and on which, what type of environment you're deploying into. So if you are building containers to run on like an EKS or on Google Cloud's, Kubernetes engine, you're going to need some people who are familiar with creating containers and getting them up and running in Kubernetes. Different cloud tools have different levels of support there, but usually you do need somebody who's familiar with whichever cloud you're using. and can help sort of administer the permissions and the deployment targets and environments. A lot of the goal of this is sort of in line with the DevOps philosophy of moving the responsibility towards the software engineers who are writing the code. So the actual pipeline steps, sort of once you have we can produce an artifact and we can put it someplace and then run it. Mostly you then want to hand off sort of responsibility for all the steps in front of that to the team working on the software. That lets them kind of say, I know what we need to do to build this. We need to make this change here. That might be a point of collaboration between, teams that are managing more of the infrastructure and teams like security that want certain things to happen. But hopefully you're able to sort of push a lot of that into the individual teams and have them take responsibility for it. That doesn't absolve you from needing to manage the actual cloud infrastructure or, physical infrastructure, if that's what you're doing.
So then are you also saying all team members should be able to change the workflow or run the workflow? Or is there in a team still one dedicated person that maybe manages this workflow and other people just use it? Like, how do you divide the tasks there typically? What do you think is best?
I think it depends on the number of sort of teams contributing to the same space. So if I were to be in a more microservice environment where, the blast radius of making a change is limited to a single service or a single team, then I'm more likely to say the team should own it. If I'm in an environment that's more of a monolith, that's more of a mono repo, in that case, I might lean more towards, we're going to move responsibility towards dedicated team, especially in a larger group. I know for a long time, the way that Facebook deployed was they built one single gigantic binary for most of the service. That's the sort of thing where I probably want like a release manager or release engineers who are dedicated to doing that. While, if I've got 10 teams and 10 or 15 services and they can really only mess things up for themselves that badly, then rather than having a release engineer on every team, or even a core group of them, I'm sort of like, they can learn what they're doing. They can take care of it.
So some people also say that CICD is not necessarily about tools, but it's more about having a certain mindset, like always be delivering, always be deploying. Would you agree with that? And would you say, like, what defines this mindset?
Absolutely. I think there's one, that always be shipping aspect of it. Like, let's get this in front of people, right? There's no test quite like putting it in production. So let's get it out there as fast as we can. Whether that is, to learn something, to be certain about it, or just because, hey, this is a bug fix, let's get it to people faster. Let's not wait. So I think that's a big part of it. I also think there is this sort of, I don't want to call it like heroic, but this idea that every piece of code you write is going to production. There's no net, there's no QA that's going to catch a mistake that you made. There's no user acceptance testing, or if you've really automated this process, nobody's going to, besides the person who wrote it and the people code reviewing it, nobody else is looking at it before it goes live. So there's a certain responsibility, I think, that comes with that. And that I've seen is hard to replicate. It's hard to tell people, think about your code as if it's going to production right now, if it's not. But then on, that first Monday when you say, okay, it's going now, you can kind of see the way people react, like, oh, okay, I need to be a little bit more thorough or more careful.
Yeah, so I think what you're saying is that the idea that you're always shipping sort of creates an urgency, creates a sense of responsibility, because it's actually going out there soon and not in 3 months or in 6 months. We can deal with this later.
Absolutely.
So how do we translate always be shipping to concrete actions? I mean, always be shipping is a bit like eat healthy and exercise more, right? Clearly, this is a good idea. But now what do I do day to day? How do I get this mindset in my team? Because it is so tempting to say, I'm in this branch. Oh, just a little bit of this. Oh, but what's also related to this feature, this, and still I'm in a feature branch. Like in my own open source project where I'm working, I have a few of these very long-lived pull requests where a contributor is sort of out there. I'm like, okay, so how do I get them to adopt this always be shipping mindset? How do we get there practically?
So I've seen teams, open source projects are a little bit more of a challenge because you have less cohesion, but what I've seen teams typically do is kind of go through a couple of steps. One is, okay, we're doing feature branches. We're doing these big, if you're starting there, some teams start a little further along this path, and every time we do this, it's a big deal. We don't deploy very often. It's risky. We have these big merges. And one of the first steps I think that can really help break that mindset is, okay, we're going to do this every week or every other week. We're going to move to sort of a scheduled model away from a when it's ready model. And that means that everything that's in there is going to go out on Thursday, it's going to go to staging, and on the next Thursday, it's going to go to production. And that's our QA window now. I think the biggest thing that does is it encourages, because you're doing deployments more frequently, it encourages you to automate those and then feel more, once you start automating pieces of it, you feel more comfortable with it. Like, okay, it's probably not going to break. It didn't break last time. And that, keeps building up that confidence.
Yeah, and I guess also this exposes issues, right? Because if you only deploy once every year, then it's like, oh, what do we have to do again? Whereas if you do this more frequently, then you have to figure out how to do stuff automatically, because you cannot think, oh, I have to set this directory to this and that, because it doesn't scale if you have to do this daily or weekly.
Yeah, if you rely on a single person, you might say, hey, they're on vacation this week, so we're going to just shift the deploy to next week. But if you are doing it weekly, then you can't rely on that person because they need to be able to go on vacation.
Yeah.
So yeah, there are all sorts of things that I think shake out. And there's the good XKCD comic about, how often do you have to do something to make automating it worthwhile? Well, a good way to force that is to do it more often.
Timescale DB from your friends at Timescale is the leading open source relational database with support for time series data. Time series data is timestamped so you can measure how a system is changing. Time series data is relentless and requires a database like Timescale DB with speed and petabyte scale. Timescale DB is the Postgres you know and love with time series superpowers. Familiarity, flexibility, speed. That's Timescale. Visit them today at tsdb.co/SERadio. That's tsdb.co/SERadio.
And are there intermediate steps? So imagine we're still in a team that has this feature branches mentality. And it's hard to go from that to, yes, but we deploy 3 times a day. So what do you do then? Do you break a feature up in sub-features and do you have people do tiny feature branches? Or do you say, no, this gradual approach is not good. You should just say, hey, as a team, we decide we're not doing feature branches. We're now doing quickly deployment. What is a strategy to move a team towards the CICD way?
Well, I think that sort of intermediate step of something like a scheduled, release train model is what we used to call it. Mozilla, which was our, we promote to different environments on a periodic schedule. I think that can be a good middle ground. I do think that at that point, you need to introduce the concept of the feature flag, because that's the point. In order to make that switch, you have to have some way of saying, if it's not done by Thursday, when we go to staging, that's okay. It's turned off. It's behind this flag. So we're able to ship even though it's incomplete. I think that that's kind of the first big mindset shift, right? Is being okay with shipping incomplete code. And that does require some tool support. But once you've got that sort of routine down, I think if you're saying we're going to start every 2 weeks, then you can shorten it. Then you can maybe shorten it to every day. And the change set gets smaller and smaller. And then at some point, you do kind of have to just rip the Band-Aid off and say, all right, the next change is going to production.
So you mentioned that this mindset shift also interacts with the tools. How is that? What tools help or what tools hurt make this shift?
Feature flags are they're kind of the one of the keys to unlocking CD and even CI. And they come with their own kind of burden at the same time. You need them, but now you also have to manage them, right? You have to worry about deleting flags when you're done. You have to decide who's going to put the flag in the first place if multiple people are contributing to a feature. And I've definitely seen a lot of teams kind of struggle with when's the right time? Should this be behind a flag? Do I need to flag every change? It's no, you can probably make that CSS fix without flagging it. It's probably all right. But, there's a big fuzzy gray area in between obviously yes and obviously no. So I've definitely seen that be a stumbling block, that not so much the use of the flag. I think for the most part, a feature flag is an if statement in the actual code, but the when do I use a flag can be a big sort of steep learning curve and opportunity. But, I think intuition is the result of experience. And once you do it a few times and sort of get used to it, you start to develop some of that.
But of course, listening to experts can be a shortcut to intuition. So do you have maybe sort of a grasp of, you just mentioned like, a CSS fix is probably fine without a flag. Like, when do I know if the complexity of my code is going over I need a flag threshold? Like, are there decisions to be made?
Yeah, so I think that one thing, depending on your sort of like product and team environment, if you're doing something that's an experiment, that's something that's probably going to be behind a flag. The difference between A/B testing and feature flags is really the branding of the tool that you're using. So hopefully, if you're in an environment where you're doing that, then anything that's an experiment is sort of automatically a feature flag. Anything where it's going to take a couple of steps to finish, or it could reasonably take a couple of steps to finish, is a spot where it might be a good opportunity to flag. Sometimes you can write code that's just inaccessible and unused and, get away without doing the flag, and that can help. But, when it comes to something where, all right, we are changing the way that this works, then it's going to take, a handful of days, then that's something where you probably want to flag it. Or anything that's just sort of risky and unknown. Like if you don't necessarily have a performance profile for something yet. A lot of the feature flag tools, most of them can do some kind of percentage rollout. So you might want to say like, I don't know how this is going to work in production, so we're going to turn it on for 10% of people just to sort of see how it scales and what sort of load it generates. So that's another good reason why you might want to flag something, just to have that kind of control over it.
And then do you typically leave the flags in forever? Like imagine at one point you're happy and then 100% of users has been using this feature, I don't know, for 3 weeks or whatever good granularity is. Do you leave them there so you can always toggle if needed? Or at one point, the feature is just a core feature? Or would you say no flags stay there forever?
If they stay there forever, it's going to start to become kind of a combinatorial nightmare. So I think a big piece of using flags and one of those costs that's associated with them is you have to go back and clean them up. A lot of teams that I've known have had a practice of as soon as we create, the first ticket to start a feature that is going to be behind a flag, we also create a ticket to remove it.
Oh, is there like a timeline? Do you say we make this ticket and it has a deadline in always 3 months, or does this depend on the type of feature?
It depends on the type of feature. I'm not sure that I've seen a team with like a hard and fast rule on that deadline, especially if it is something a little riskier and you might go back and forth on it. Part of the point of feature flags is to be able to turn it off if something goes wrong, which if that happens might extend your timeline. I think it's more about what is kind of the total load of flags your team can be maintaining at once than the lifetime of a particular flag. So if it's to this point where, you've got a team of 5 people and 30 or 40 flags in your application, that's just by itself introducing a lot of complexity and a lot of code that might be unused. So starting to remove them is going to be more important as they kind of pile up. I think more so than strictly speaking the time. That said, I've also seen people introduce a flag in one working on a particular ticket, ship something, turn the flag on, and then as part of the same ticket, remove the flag, just because they wanted that kind of safety. And often with stuff that small, the flag might live for hours.
Yeah, that makes total sense. So let's talk about data, because most applications nowadays have data in a database. Sometimes a new feature might require migrating data, like adding a certain column in a database table in the front end, might mean that existing users that did not yet have this field object need to be initialized or get a default value or maybe generate a value from already existing data. How does that figure into the equation? Like, do I first integrate just the migration of the data and then the front end, or is this then maybe a bigger package? How do we deal with features that require changes to existing user data?
One thing I think is that these problems can be very fun. I really enjoy zero downtime deployments and zero downtime changes. So I think the first thing is to ask yourself honestly if that's necessary. Because sometimes it's not, right? If you have a very geographic user base, you might be able to say, we're going to do this offline migration. We're going to take 20 minutes in the middle of the night. We're just going to do it. If you have services that are facing like a call center or an operations team that, has specific hours, sometimes it's okay. Even a minute of downtime might be totally acceptable. So I think the first thing is to really say, is it going to be worth it? But let's say that it is worth it because this is a fun problem. So there are a couple of approaches that I've seen for this sort of migration. I think the one that I tend toward is try the new path. If the new path doesn't work, fall back to pulling data from the old path and migrating it on demand. That's going to introduce some additional latency for people the first time they go through because there's a little bit more to do, but it prefers the new data if it's available. So, as the more frequent users or the first people will start putting load into the new system, depending on what the feature is, you may want to double write data if there are changes into both old and new versions, if that's applicable. If it's a new feature, there may not be anything to put into the old one, but at least for a while until you're confident in the new system. And then you can also kind of look at, if you've instrumented this, you can look at what percentage of our requests are falling through to the old path. And that's a fun graph to watch. So I've usually seen this as kind of a 3-step process that I would love to have a name for, if anybody knows one, of introduce this new path with fallback to the old path. Eventually, you're probably going to have to do something for the people who haven't logged in if you're doing that kind of online migration and do a backfill. That can usually be done slower and in batches. And then go and remove the migration code, and now you're just on the new path.
Yeah, so then maybe you have those sort of flags. Like there's a flag for we have released this feature, and there's a flag for have we actually migrated everyone to the new data structure.
Yeah, and maybe one of those flags could be dependent on the other. There are some tools that let you do that, where flag A can only be on if flag B is already on for a particular user. Or, one of them might be user-based and the other one might not because you're doing this on the back end.
So this is interesting. This flag A can only be on if flag B is already on. Where do you manage that? Is this somewhere in your code base? As you said, the flag is just an if statement? Or is this additional layer in a library or in the CICD platforms?
So one of the really interesting things to me about feature flags is that the goal of a feature flag tool is to separate the conditions under which something is true from the code that cares about whether it's true. So in the code where I'm writing the feature, all I should care about is this flag on or not? That's the question that I'm asking. The feature flag library, usually, it might be a client for some kind of server. It might be a library built into the code that's managed someplace else, then has certain sets of conditions that make it true. So the easiest condition is it's on for everybody or it's off for everybody. Then you can get into it's on for authenticated users, or it's on for people from this IP address block, or it's on for people on iOS but not on Android. Whatever kind of set of criteria or set of features the tool supports. So there are tools like LaunchDarkly that support a lot of things out of the box, but allow you to write custom rules. Often you will have to initialize a client like this with some kind of user context. But the idea and the real power of it comes from being able to separate those conditions and those triggers from the places that care about the result.
And then those conditions are also described in something like a YAML file. Or does this live in a function that you inherit?
That depends a little bit on which tool you choose to use. If you want something like feature flags as a service, and there are a handful, or even some open source versions that it's a feature flag service that you run internally, then that is really state of the feature flag application that you can configure. One of the real powerful things there is that because it's application state, it's not a code change to turn something on or off. So you could even have, a product manager go and say, I'm going to hit the release button because it's 9 a.m. on Tuesday. And that's when we said we were going to turn it on. But by separating it out from actual source control, that sort of gives you that ability to say, oh, we deployed it and there's a problem we were talking about earlier. I'm going to turn the flag back off.
Yeah, without deploying again. Just the code keeps running
again
as it is. Mm-hmm. You just turn a Boolean out somewhere. So let's talk about programming languages. You already sort of hinted at there are some differences between different programming languages because, for example, if you compile to a binary, it's very easy to go back to a previous version if you still have the binary somewhere on the shelf, so to say. You can just grab the yesterday's binary and put it back out there. Also, some programming languages, of course, might have longer compilation times. So are there important differences in CI/CD tools or practices between Java or Python or TypeScript? Or would you say, that's all by and large the same?
I think all of them have some commonality. For example, all of them should be able to run a clean build from scratch, which might be the slowest version. You might need different levels of, I would say, start with what your performance targets are, and then work backward to see sort of what you need to do to achieve that. So, for example, something where you're pulling in a lot of dependencies from whether it's like Python or JavaScript or Ruby from a third party, that step might take time. So you might want to cache those. Like most caches, I would say, don't do it right off the bat. Do it if you find out that you need to. And different languages are going to have different performance, realistically different sort of performance characteristics of their package ecosystems. Like you said, compilation times. Some languages support incremental compilation. If you're caching or keeping around the sort of build environment and you're using something like Go or like C, with a well-constructed make file that can do that kind of incremental compilation, then that might be faster and might be something you want to enable. With, I think, always the capability to be able to say, like, no, do it from scratch, clean the build environment, start over, just as a baseline. But I like to work backwards from what am I trying to achieve? Can I get this build to be under 5 minutes? If you're running certain linters, the answer is probably no.
So sort of 5 minutes, is this a realistic goal or an important goal, or does that depend also on what you're building?
I think it's realistic. I think the important goal is how distracted am I going to be as a developer when I hit the merge button and then let this process start? Am I going to be sitting there for half an hour trying to remember that I'm waiting for this to happen? The shorter you can make that feedback loop, the better. I think 5 minutes is definitely doable. A number of the backend services and front-end services, actually, we've gotten our sort of deploy time from merge to production to be under 6 minutes. Our reports only go to the 10th of an hour, so I think they're faster than that. So I do think it's a reasonable, for decently large applications, to hit that target. But yeah, it's really about attention for me, because one of the goals here is to, we talked about the example of like, oh, I wrote this and then 3 months later it got deployed. Like, I don't remember what that was. I have no idea what I was doing. So if I can stay kind of in that headspace of like, I'm shipping this, I'm watching the monitors, I'm watching logs, oh, that's a new error, I can see how that's connected to the code I just wrote. So kind of keep that context. The longer your build time, the harder it's going to be for people to do that.
Yeah, and also I guess the longer the build time is, the harder it is to do it often. Because if I have to wait for half an hour, I'll do something else in between, I'll come back. I don't want to do that 2 times a day.
Right.
That's annoying. Whereas if just a click of a button, it doesn't really matter.
If it is a single environment, that is a hard limit on how many times even multiple people can deploy per day, right? If it takes half an hour, you've got 48 deploys.
So you mentioned that there are definitely commonalities between different programming languages, but maybe there are also differences. So what are some differences?
Well, a big one is, whether or not it produces a binary by itself. And that's something that you can move around. Or if you're doing something like containers, that might not be as important because you can treat the container as an artifact as a binary. But if you're doing, Python environments, shipping those to servers can be tricky if you're not using containers. So one of the things that I've seen is, each production server that this is running on has to go through some of the build steps by itself, just because replicating that environment requires it. I think that's a good reason to use or move towards something like containers if you can. That said, adopting something like Kubernetes is a lot, and it may not be for everybody. Whereas, if you're moving a Go binary or a Java jar around, that might be a lot simpler because it's just like, okay, here's the file, it'll run. We, cross-compiled it or whatever we needed to do. So I think that that's a big difference, like whether or not you have at the end of this process a binary artifact. There's also, if you're dealing with front-end languages, what deployment means might be entirely different. I need to get static files someplace. I need them to be on a CDN where browsers can access them. I might need to point something somewhere at a new URL to download those static files. That can also sort of really change your final steps. Like maybe deployed into an environment means that CSS and JavaScript bundle is in a bucket now, which is a very different process from kicking off new containers. So there are very much sort of results towards the end of the pipeline that depend on the languages and the environment that you're building into.
And I guess maybe also a bit on the architecture, because if you have a monorepo, everything's in one place, then the flags and the process just lives there for this thing. Whereas imagine if you have microservices, then maybe I need to deploy 3 or 4 services, redeploy with a certain flag, and maybe the other ones are just, they remain as is. They're not impacted by that change. So I guess architecture also plays a role there, right?
Absolutely. I used to maintain for a long time Waffle, the feature flag tool for Django applications, and I'm no longer sort of the day-to-day maintainer of that. Sometimes you have to move on from open source projects. But one of the reasons that I kind of moved away from it was that it's not an effective way to manage those sort of microservices. And that's a case where you want flag state to be effectively a cross-service global, right? Like every service should read the same state for that flag. So that's when something like a feature flag as a service, either SaaS product or something that you're running internally, is really important. So yeah, you might exactly have that kind of situation where, hey, 3 things need to pay attention to this at the same time. In a monorepo, maybe I just deploy all of them at the same time. I make the change in one commit, right, across all of the services or all of the components of the code. Whereas in microservices, it's like, nope, this has actually got to be spaced out now. There's no way that I can coordinate that all of these will change at exactly the same moment. Although, again, sometimes one of the things I've had to learn is that it's okay for there to be, it might be fine for there to be 30 seconds of downtime in the middle of the night or something. It's all right. I don't like making changes in the middle of the night, though. I like making changes when I'm awake. So I tend to.
Yeah, I think there's research that shows that these deploys on Friday afternoon or Friday evening are always more likely to introduce bugs, just because people are tired and they want to have the thing over with. So it is maybe not a good idea to deploy when it's late night for you.
Right.
Maybe when it's late night for your customers, it's fine. But if it's late night for you, then you just might not be in your best mind at that point in time.
Yeah, I think it's all about, are you going to be there to support it for long enough that you feel confident, right? So if I'm working till 8 on a Friday, I'll deploy at 6. I don't care. But if I'm trying to leave for the weekend, it can wait. That'll go on Monday. It's fine.
So I think that's most of what I wanted to ask you today. Is there anything important, any life lessons about CICD that we've missed? Any advice you want to share with our audience?
Well, one thing that I think is been a real learning opportunity, or thing that I've gotten to experience several times, is that a lot of these things are improvements, even if you don't get all the way to continuous delivery or deployment, right? If you have the ability, if you think that you're doing trunk-based deployment and you think that that branch is ready to go at any given point, even if you're not actually doing it, there's a lot of practices that you've adopted that are going to sort of help. The other thing that we haven't really talked about, but I think is a very important aspect of this, what I would call the Triforce of Wisdom component, is having insight into the system. We touched a little bit on monitoring, but this is a whole range of, do I have observability tools in place? Whether that's metrics or logs or spans, or doing request traces or whatever the appropriate thing for this environment is. Can I see how the system is running? Can anybody file an issue if they see a problem, right? Like anybody in the company, anybody in the team should be able to sort of raise a hand and say, hey, I noticed this, or hey, a customer emailed me about this. Or, we have a customer forum. I think Etsy has a seller forum that they watch for quality issues, just to keep that feedback loop tight. I think that that's a really important aspect of doing this successfully as well, is having that insight into, is it working right? Are there things that I'm unaware of that other people might be, and can they surface that?
Yeah, and if people want to know more about that specific topic, we just recently had a show on analytics. That was show 496. So if you do want to dive into that side of monitoring and understanding what's going on in the application, then definitely we will put link to the show 496 in the show notes. Talking about
Perfect.
The show notes, is there anything from your side that we can add to the show notes? Like, where can we follow you, your work, any links we should add to the notes?
Well, my website is just jamessocol.com. And from there, you can find Twitter, GitHub, my blog, which is called coffeeonthekeyboard.com, which I would consider changing, but it's been around for so long that there are links to it. So
It is cute.
yeah, it's got a brand to it, I suppose. But yeah, everything is sort of linked from my website, and I have a draft that I need to that did not survive blog backend transition that I need to rewrite, but I want to publish it this week about the Triforce model, because I've talked about it a few times, and I figured I should write it down.
Yeah, if you have that post, if that's live when we publish this episode, we should definitely add that to the show notes.
If it's not, I'm going to be very disappointed in myself.
Well, this is maybe a good deadline for you to get it finished in a few weeks.
I think so.
Okay, I guess that's it. Thank you so much for being on the show with us today, James.
Thank you for having me, Felienne. It's been great talking to you about this.
Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can comment on each episode on the website or reach us on LinkedIn, Facebook, Twitter, or through our Slack channel at seradio.slack.com. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under Creative Commons License 2.5. Thanks for listening.